So, hello everyone. So for our practical machine learning and for final HiCom project, so our objective was to develop binary classification module to predict whether the person has a predict debit or debit using the behavior health survey data. So debit is just one of the most prevalent chronic disease in the United States, which is affecting over 34 million Americans and nearly 88 million individuals with a pre-diabetes remain unaware of their condition. So the early detection is extremely important because the complicant such as cardiovascular disease and kidney failure and also vision loss are strongly associated with a prolonged elevated blood glucose level. And so that predictive module based on lifestyle and the demographic risk factor can support early screening and public health intervention. So in this project, we just used the BRF that 2015. There are two CSV data which contain approximately 10 a survey response and 21 behavior and a health related feature. So I use so there is a class request. You can see the collapse. I'll scroll down. Is class imbalance versus balanced. So now before the building our module, we first explore the class distribution. So as you can see, we from the count plot in notebook, the data set is clearly imbalanced. So the number of individual without diabetes is significantly higher than those with a pre-diabetes or diabetes. So because of the imbalance, by using the accuracy as our main evaluation metric would be misleading. So, for example, a module could achieve high accuracy simply by predicting every individual as non-diabetic, so that we choose to evaluate to our module performance by using F1 score, so which balance both precision and recall. So which you can see that guys, you can see the graph. This is especially important in the healthcare prediction task. We're identifying true positive case in critical. So, but the third one is removing a duplicate. So next we check. You can see the code above that the collapse. So, we check the duplicate row in the training data set. We identify over 7,000 duplicate entry in the original training data. The duplicate sample can lead to the overfitting because of the module can memorize repeat pattern rather than learning generalizable relationship. So the all duplicate row were removed before training to improve the module generalization perform to the unseen data. So next is talk about correlation metrics. I mentioned on the code for the collapse. So after cleaning the dataset, we examining the correlation metric among the numerical feature. This allow us to understand how strongly different health indicators are related to each other. For instance, BMI shows noticeable correlation with general health status and physical health measures. So to understanding feature relationship is useful for detecting redundancy and ensuring that our module does not really exactly on highly predicted. So next part is the regulation. So to further prevent overfitting, we apply to the regulation within our GBM module. Especially we use L1 regulation through the reg alpha parameter and L2 regulation through the reg lambda parameter. So L1 regulation helps shrink important feature with 2 or 0, so which effectively performing feature selection. So L2 regulation discourage large weight and which is improving module stability. So together this technique improves generalization to reduce variance when predicting on unseen test data. So now the next part, which is the PCA. You can see the graph, the PCA dimensionally protection visualization. So we perform the by using principal component analysis. So although PCA was not directly used for training, it provides insight into how well the data set can be represented in the lower dimension space. So by projecting the feature into the two principal component, we visualize the overall structure of the data. So this like help access the whether meaningful pattern exists between the diabetic and non-diabetic groups in the feature space. So this will be like explaining like various ratio, also indicating how much information is retained after dimension reduction. So now it's about like a Zabo module, which is include like GBM and CV. I use this module to calculate the F1 score for this project. So we use the light gradient boosting machine learning and or lag GBM. The lag GBM is enable learning algebraic based on a gradient boosting decision tree. So unlike the single decision tree, the Zabo method which combine multiple weak learner to improve the predictive accuracy. So we just implemented, which is like fivefold stratified like cross verification to ensure that the class proportion are preserved across the training and the validation split. So which allows to obtain more reliable performance, which that estimate and reduce variance due to the random sampling. So additionally, we finally adjusted the scale post weight parameter to address the imbalance problem between the diabetic and non-diabetic classes during the training set. So now is the feature importance. So after training, we just like extracted feature importance sources from the module. We observe like BMI, age, general health, and income, and so on, were among the most influential predictor of the diabetes risk. And now is the important part is the confusion metric, is TP or TN. So next, we just evaluate the module performance by using the confusion metric. So this allows us to interpret like first true positive and true negative and false positive and false negative. You can see the results on here. And and in our result, the module correctly like identify over 9,000 diabetic individuals. So next part is FP and F1 cost discussion, which is healthcare. So in the healthcare screen task, the false negative are typically most costly than the false positive. A false negative, which means that failing to detect at risk patient, potentially delaying treatment. So in contrast, a false positive may only result in additionally screening or monitoring. So that which is improving recall is particularly like important in this context. So for final power, we just use the final metric is our auto-fold evaluation produce the following result, which use the accuracy, precision, and recall and F1 score and ROC AUC for right here. And the ROC AUC score above the 0 point indicates strong separately between the class. So for in conclusion, I was gonna say like by combining example learning, the class imbalance handling, and also the threshold turning, we are able to develop predict module for the diabetes risk based on the behavioral health indicator. So which is this approach demonstrate the potential of the machine learning in supporting early disease detection and also public health decision making. Thank you guys.